Good morning, everybody. So a few days ago, I put together a blog post called Another Day, Another Hack, which looked at this Fidelity Investments hack, which exposed 77,000 customer records. The exact details of what happened are still a little bit thin on the ground. I guess it'll come out in this class action lawsuit. But one of the things that seems to have happened is there are some sensitive document images that were stolen. I'm guessing this is ID images, so scans of people's driver's licenses, scans of utility bills, the standard proof of ID for opening accounts. And that really surprised me because how did it happen? Anyway, so I thought I'd put together a bit of a starter post on creating a database, creating a table, and not only encrypting plain text, so maybe we want to encrypt someone's social security number, their national insurance number, their address. So plain text, I want to be able to encrypt it, and for the right people, decrypt it. But I also want to be able to take a scan of a sensitive image, encrypt the image, so encrypt the JPEG or the PNG or whatever, store that in the database, and also to be able to decrypt it and see if we got a perfect copy of that ID. But I also want to show you how, if we then move that database to a new server, effectively trying to steal the data, the plain text is protected and also the scan of someone's ID is protected. So the first step is we are going to just create a very simple database. You can do this by right-clicking New Database in SSMS. This is a little script I've got to put together. It creates a database called MyDB, and it's going to create an MD, primary data file and a log file in this SQL Server data and logs directory. Please feel free to modify it as you see fit. It doesn't do anything more complex than just create a database. Okay, we should see it. We refresh Object Explorer, there it is. Now, I want to create a table that's going to store our secret text and our secret image. So the script for this is on my blog. Very simple table, creates an identity column, row ID. I create a GUID, which I'm going to call text ID. I'm going to use that as a cryptographic sort. I'm not going to go into sorts. I've left a link on my blog if you wanted to go down that route. Please don't worry about it too much. We could have done it without a sort, but this is just adds an extra layer of protection to this. Here's my column for my encrypted plain text, which I'm going to call secret text. And here's my column for the encrypted image of that sensitive document that I'm also going to store in this table. Okay, so if I run this, I should create the table. Great stuff. So I should have one table, my TBL encrypted table, and there it is. Okay, so let's begin. So I find this diagram quite useful because it really shows the steps that we need to do in order to encrypt our data. So the lowest level is the encrypted data. So we start off by creating a database master key. I'm going to then create a certificate. I'm then going to create a symmetric key, and where I'm going to use all of this together to encrypt the data. And I'm going to keep coming back to this diagram at various stages to show you where I am. So the first step is create the database master key. If I switch context to my database, I'm going to do a select star from sys.symmetric keys, and it's a blank database. I just created a table. There's nothing else in this database at the moment, so selecting from symmetric keys reveals me nothing. The script to create the database master key is here. It's pretty simple. Switch context to your database, create your master key, encryption by password. So this is something important here. When we create, if we're going to encrypt by password, use a strong password. Don't store it in with any other SQL files in your source code control or anything like that. Store it, don't lose it, don't share it. I'd recommend storing it in some sort of corporate some sort of corporate vault like KeePass. I've seen corporations use that. I use KeePass myself, quite like it. We're going to need that password when we move the database to another server. I'm going to show you how, without that password, your data is protected. So let's create the database master key. Command completed, OK. I'm going to switch back to have a look at what's in sys.symmetric keys. And there we go. We have our database master key created today and the key good for it. Great stuff. OK. Next step, we go back to our diagram is, in this case, I'm going to create a certificate. To show you there are no certificates at the moment, I can switch context to my database and select star from sys.certificates. There is nothing in there. I can also expand the security node within my database and have a look at certificates, and there are no certificates there. Okay, great. So let's create a certificate. I'm going to give it a sensible subject. Just going to call it for encrypting our secrets here. So use my DB, create certificate, cert for our secrets. Okay, certificate created. So if I switch back to this window, I should see certificate for our secrets encrypted by the master key. The issuer name is for encrypting our secrets. Going back to our diagram, we have created a database master key. We just created a certificate. So our next step is to create the symmetric key. I can also have a look and see that there in the security node, symmetric keys, we don't have any symmetric keys created at the moment. We do have the database master key, which I can see from the SQL command. Switch context to my database, create symmetric key. I'm going to call it sim key for our secrets. Whatever naming convention you or your corporation want to use, just stick to something sensible. And I'm going to encrypt it by a certificate that we just created, which is our cert for our secrets. So run this. Commands completed successfully. If I refresh my security node, I should see my symmetric key there now. And I should also see it from our use my DB, select star from symmetric keys. So I should have my database master key and my symmetric key that I just created. So we have now done this step, database master key, a certificate, and we've created the symmetric key. So we should now be ready for the encrypted data. So here's my script for encrypting some plain text. I'm only going to populate the secret text column at the moment. So basically I'm switching context to my database. I'm doing everything within a begin, try, and a begin catch block. So if there's any errors, we can handle errors here. Say, report back to the user what they are and the line that they occurred on. So the setup is some plain text. So I want to encrypt this text. This could be some really big text to encrypt. And I am going to I'm going to set my salt, my cryptographic salt that I used. Like I said, I don't want to make this more complicated than it needs to be. I'm just generating a new GUID just to create something random. The next important stage is to open the symmetric key with the decryption by the certificate. If your account does not have the rights to do this, this will generate an error. So this is why protecting access to that symmetric key is important through your standard SQL Server permissions. Okay, so to encrypt it, I'm going to store the return from the encryption by key, which is the internal SQL Server function, which returns to me a var binary, and I'm going to store it in this variable here. The key GUID is telling the encrypt by key to go get the unique identifier for this symmetric key, which we just created, the SYM key for our secrets. I'm passing in my secret text, and then I am using my salt here and a SHA-2 256 as the algorithm with which to hash this up. So I can't always remember exactly what to put in there, but I remember the basics, which is remember your key, pass in your plain text. If you have a salt, then use the salt within this hash bytes and your algorithm with which to hash it. So I should get, hopefully, my encrypted version of the plain text back in this variable. I'm then going to insert it into our table along with the salt that we use, because we're going to use that in a little bit. And that's it. So if I run this, one row affected, excellent. So if I select from my table, what I see is the encrypted version of the plain text, which for anybody looking at this table now, as an attacker or as someone who maybe you don't want to be able to look at what the actual decipherable text is, they're just going to see this junk. So that's all very well, unless as an authorized user I can also decrypt it to get the plain text, because I might want to check someone's social security number or their address or whatever, the sensitive data. So I need to be able to get it back out again. So this is my script for the decryption. Really it is not, it might look more complicated than it is, but it really isn't. Switch the context of my DB. I'm doing everything within this begin try, begin catch. So any error handling down here, such as the error message, the line it occurred on. Then I'm just starting a setup. So I only added one row to this table. So I'm just saying, go get I want to decrypt secret text for row 1. This is going to store, hopefully, my decrypted version of the encrypted plain text. And I'm going to go get the encrypted var binary from the table, which is in the secret text column, with row ID equal to 1. So as soon as I've got the var binary, what I'm going to do is, before then, I also want to get our salt, which is in the text ID column. I open the symmetric key again, exactly the same way. Open symmetric key, the name of our key, and the decryption by the certificate we created. This is the real crux of the whole thing, as I'm going to use the internal SQL Server function decrypt by key. I'm going to pass in the encrypted var binary encrypted text. And I'm passing it just like I did when I did the encryption. I'm using the hash bytes function. I need to know the algorithm, which is the SHA-2 256. This is what we use to do the encryption. So now I'm doing the reverse, so I've got to use the same algorithm. And I'm passing in the salt into that hash bytes function. So this is really the key bit. Remember the function name, passing the encrypted, what you want to decrypt, and then handle any salt that you might be using here. So if that works, I should report back to the user the encryption and the plain text, if all that works. So it does indeed. So there's the encrypted junk that you can't decipher. And providing I've got the permission with which to open this symmetric key, then I can get that plain text back again. So obviously, like I said with the encryption, we want to protect that symmetric key as much as possible. And when we move the database, what I'll do is I'll show you that without knowing the password of that symmetric key, even if you attempt to open the symmetric key, it's going to fail. So your data should be safe. So here I have a real simple script. I use it in a lot of places with agents and so on. So I'm going to back up my DB. Today's date's 15th of October. It's a full database backup to SQL Server backup. So if I run that, okay, backup processed correctly. And there it is. There is the backup. I'm now going to move this database to an entirely different server. I'm going to restore it in the way that I would restore any database. And what I want to show you is that let's assume someone got hold of your backup, or they got permissions with which to take a backup and then steal it off of your corporate servers and put it onto one of their servers. Can we then just open that symmetric key like the SQL that we were just doing and decipher the plain text? So I'll show that in operation. Okay, so I've restored that database onto another server. I want to, because it's not my development server, it's another small server, but it's a public facing server that I don't want to reveal too many details about. So there's a small script here that basically says if I'm not on my development machine, then report back that I am not on it. Otherwise report that I am on it, then display all the certificates, all the symmetric keys in the data that we just encrypted into our little encryption table. So the report back is that I'm not on my development machine, but here is the certificate that it's found. Here is the database master key. Here's the SYN key for our secrets, and there is the data. So everything is there. So I've taken that backup from my development box. I've put it onto another server. So I'm mimicking having been able to take a database backup or steal one, or in some way get the entire database off and onto another box. I ran the same script on my development box where it says I am on my development box. There's the certificate master key, the symmetric key, and the data. And I just wanted to show you the key GUIDs are identical so that you can see this really is a complete restore of the database but running on a different server. So I'm now going to rerun my decryption certificate. I'm going to rerun my decryption SQL. But I want to see what happens now, because this is the exact same SQL that I ran on development where I could get the plain text deciphered. So if I try to do this now, what I get is please create a master key in the database or open the master key in the session before performing this operation. And my results are that I can still see the encrypted text. So this row is coming from here. But my secret text, the plain text, is null. It's protected. And it doesn't matter what I do, I will not, my data is secure even if the entire database was stolen. So the next step is to show you what if I really wanted to restore that database and make it operational and give people, the appropriate people, the permissions to be able to decipher that encryption. So here we go. So I now want to make that database operational, my DB, so I switch to context. I open the database master key by its password, and that's what I was saying. Do not store this password anywhere, not in the SQL, which could go off to your source code control or be stolen by someone poking around your SQL files or your raw source code. Get it from your vault. So I'm going to open it. I'm then going to alter it using the server's master key, the SQL Server master key, and I'm going to close it. So without this password, you're never going to be able to decipher that encryption text. So if I run that now, completed successfully, I return to my same decryption SQL that I have here, and I now have an operational system again, and providing I've got the ability to open the rights to be able to open that symmetric key, I can get that plain text back out. So that's demonstrated moving the database to another server without knowing the password for your symmetric key. Your data is going to be safe. If you are an authorized person to be able to do this and you have the password for the symmetric key, you can move it to another server and keep your system entirely operational. Okay, so back to my development box, and I want to encrypt this PNG image, which I'm just gonna open with Paint, good old MS Paint. And this is my sensitive image. Even if your entire database is stolen, the sensitive data is safe. Okay. So let's do that as the next step. Before I do that, I'm going to clear down all of the data in my TBO encrypted table. So let's delete everything in the table. And because I've truncated it, now when I insert a new row, I should be back to row ID equals 1. And here's my script for encrypting secret text and secret image. The text part of this is really no different. I'm opening my symmetric key here like we did. I'm doing my text work here, so I'm encrypting the same plain text using the same encrypt by key function that we did earlier and our salt. I am then going to get the raw unprotected image from disk using OpenROSAT, so that's the path to my sensitive image. I'm then going to make sure that I got the image okay, and then I'm going to encrypt in exactly the same way. I'm going to use the same salt, the text ID, but I pass in the raw binary image, that the unprotected PNG, JPEG, whatever you want it to, whatever binary you want to encrypt really. And then I'm going to add the data, so the encrypted text and the encrypted image to the table. And I'm going to raise any errors if there are any issues. So if I run that, okay, so got the image from disk, okay, so that's the raw unencrypted image. Then the data was written to the table, okay, so that's the encrypted version of the plain text, and that's the encrypted version of the image. So if I go to delete my image, now I've used it and encrypted it. I'm going to move out of the way my backup that we just did to prove that we could move and protect data. And now I'm going to try to get that data out of the table, the encrypted version of it. So this is my script for exporting a binary column from a table to disk. So I am going to store the output into a file called sensitive image export not decrypted PNG. We imported PNG, so I'm going to export it, and I'm going to get the secret image from here, store it in this variable. I'm then going to attempt to use some SQL Server stored procedures to create an ADODB stream. Open, write, save to disk at that location, and then close that stream off. If there are any errors, I'm going to catch them here, destroy the object. If you get the following error message, which you probably, I did, you probably will do, it's just going to be a message about being blocked access to some of these stored procedures. You might need to run these sp configure commands. I've already set this up, so if I run this, completed successfully, so I should have a file on disk now. And when I attempt to open it, I get nothing. So the data is protected. But this isn't any good unless we can get back to the original document as an authorized person with which to do whatever you want to do corporately, check their ID. So here is my script for decrypting the secret text and the secret image. So I switch context to my DB again. I set up some variables here. This will be used to store the decrypted versions of secret text and secret image, and this is where I am going to put my decrypted sensitive image onto disk. I'm going to open the symmetric key just in exactly the same way as we've done before. I get a hold of the encrypted text, I get a hold of the salt, I decrypt the secret text using the decrypt by key function. I then decrypt the secret image. So first of all, I get the encrypted image from the table, store it in this variable here, and then I decrypt the image in exactly the same way using the decrypt by key function. I check on the results just to make sure nothing's gone wrong. And then finally, we do exactly what we just did in the previous script. We export to disk. However, this time we are exporting, hopefully, the decrypted version of the image. And then do any error handling, cleaning up, and hopefully, if I run that, my report back from my script is this was the encrypted text. The plain text got deciphered okay. This was the encrypted image, and this is the decrypted sensitive image. So if I go to disk now, I should have the decrypted version, which I hope if I open in Paint will be our, yes, perfect. Even if your entire database is stolen, the sensitive data is safe. So that walks through the whole process, the setting up, create a table to store your encrypted data, create database master key, create a certificate, create a symmetric key protected by that certificate, encrypt your data, decrypt your data, move your database to another server to still check that which you need to do as part of your cybersecurity testing framework, that even if the database was stolen, it cannot be deciphered. And also we tested that if you move your database to another server, we can still have the system operational, provided we know what the password to that symmetric key was that we created. And also that we are able to get back out of the database the decrypted sensitive image, which we might need for operations. And that is the whole process, which was a lot of fun.